Next up, we're going to hear from Kevin Loyens. Kevin is the Vice President of Business Development at TAM International. He's a global leader in logistics and transport of hazardous and radioactive materials, and he's going to share some thoughts about the transport of radioactive materials. So, everybody, please welcome Kevin Loyens. Thank you.
Thanks, David. Thank you. Thanks, everybody. Yeah, really thankful, Curtis, Mark, everybody here of Energy Fuels, to be here. It's my first time in Blanding. I'd been to Moab before, which is gorgeous. First time here, and it's great to be here. We've been moving material in and out of this site for many years, and it's great to actually see it. And I'm excited. I'm doing a tour this afternoon, so really excited. Um, I realize I'm probably in between. You guys are in between me and lunch now, so I'll do my best to be efficient. And I'm going to talk a little bit about the. Let me see here if I can get to my presentation. Oh no, that's it. So I was asked to talk a little bit about the world of transportation of radioactive materials. Transportation is often a little bit the forgotten child of industry. People assume that things just show up or don't show up, but it is definitely, especially I think since COVID, it's become an industry that's being looked at more and more. If you want to have a strong supply chain, you need to have strong transport systems in place. And that is what we as a company do. And we've been partnering with Energy Fuels for many years. And so the goal of my presentation is a little bit to give you an introduction of what we do, what does it mean to ship radioactive materials around the world, and how is it different from regular non-hazardous materials? What comes into play? What are some of the issues? And we'll look a little bit to the future as well of what challenges are ahead of us. Very briefly, TAM International, we're a Canadian corporation founded in 2004. So we've been around for 21 years, headquartered in Saskatoon, but we have offices in different parts of the world to service our customers. I'm in Vancouver on the West Coast. I'm the only one there. We have an office in Montreal. In the US, we have our office in Paducah, Kentucky, where we work closely with the uranium conversion facility of Honeywell, Solstice now in Metropolis. Steve Hansen, our Chief Compliance Officer, he's from our US office. He's here as well. We have offices in Europe, in the UK, and in Germany, in India, and in Brazil. We are a logistics service provider. We manage end-to-end solutions for transport of radioactive materials. So a customer who needs radioactive material moved from point A to B and needs an end-to-end solution that covers regulatory compliance, packaging, actual transport, will knock at our doors and we will help them. As mentioned, we work globally. I'm thankful for Matt to showing the nuclear fuel cycle of uranium ore going to converters, going to enrichment companies, going to fuel fabricators. TAM is a company that moves these materials in between those different steps in a nuclear fuel cycle. In addition to that, we're active in the rare earth space as well, and we're partnering with Energy Fuels on that as well for shipping their monazite feeds. We also are involved in medical isotopes and in low-level waste. So the common denominator is radioactive materials, but we're covering a wide variety of industries. That's for TAM. On nuclear transportation, radioactive transportation, just briefly as an introduction, one of the key things is it's a highly regulated industry. Transporting radioactive materials is probably the most regulated commodity that you can move. And that is the same across the globe. It's called Class 7 for a reason. The United Nations, they divided all the hazardous materials in 9 different types, 9 different classes, ranging from explosive to toxic materials and so on. The Class 7 is radioactive. So anything that's radioactive is categorized under Class 7. The source of the regulations are the IAEA regulations for safe transport of radioactive material, SSR. That's basically the guideline, the basis on which other regulation is is based. And they have developed these regulations, which then have been adopted by a variety of international organizations, such as the IMO, the International Maritime Organization, that regulates transport on oceans. So they've adopted the regulations from the IAEA and incorporated that into their own regulations. The same for different countries. The United States has incorporated those regulations in CFR, Canada and TDG, in Europe the ADR regulations. So the regulations are very similar across the globe. So if you move radioactive materials from the US to China or from China to the US, regulations are very similar. There's always small changes that each country can adjust and change, but overall it is very, very centralized. One of the key things that probably differentiates radioactive from other commodities, including other hazardous materials, is the very stringent approach and very strict approach to packaging. Depending on what kind of commodity that you move, depending on the radionuclide that is used and the activity of the material, you will need a different type of package. The higher the risk profile of the commodity, the higher the requirements on the package, which makes sense. The higher the testing requirements for such a package to be approved and regulated. I'm not going to go into detail on this. If you have any questions on packaging, I refer you to Steve Hansen, our Chief Compliance Officer. But just to give you an idea, there is a very graded approach and a very logical risk management approach to what type of packaging that needs to be used. So we have our regulations, we have our package that we've chosen depending on the commodity. Now we're going to move our material. And radioactive material can be moved in any mode of transportation, just like other goods. You can use ocean, you can use trucks over land, you can use rail, or you can use air for samples, for instance. So it seems very simple. Or is it? It's not. There are quite a few restrictions on just the reality of the world of transport. Although you can use any mode you want and there is no real limitation on it, there are specific issues at different jurisdictions and with different modes. Rail is very commonly used here in the US, also in Canada, for large commodity moves across the continent. But despite Canada, the country where I'm from, being one of the largest uranium producing countries in the world, neither CN or CP, our two main rail operators, allow any move of radioactive materials on rail. So we cannot move the material from mines to a port, for instance, on rail. We have to use trucks. That is not uncommon. There's a lot of countries that allow rail, including the US. And it's often linked with perception and risk, and I'll talk a bit about that later. In other countries where rail is allowed, there are restrictions. You cannot use any train. You cannot just use any kind of rail car. So despite the fact that rail is an option, it not always is. Like, the reality is often different. Trucking. So if you can't use rail, you use a truck. And a lot of the uranium is being trucked. A lot of the uranium-related products, natural UF6 and enriched UF6, is being trucked. But also there is limitations. To use Canada again as an example, in Canada there are about almost 70,000 for-hire trucking companies available. Now, TAM, one of the things we do is any trucking company that we use has to pass an audit. And the audit is, we will look at the trucking company, we'll make sure, do they have the required training? Do they have the permits in place? Do they have the right quality and safety management systems? Do they have the right insurance in place? So of those 70,000 for-hire companies in Canada, there's somewhere between 6 and 8 that actually pass the audit, that we can use, that are trained, that have the required qualifications in place. We see the same in Europe. In Europe, there's about 2 to 4, 3 to 5. UK, there's basically 2, 3, depending on what commodity. The US is no different. There's a lot of trucking companies in the US, but the ones that really are capable and trained and qualified to move radioactive materials is limited. There's probably 4 or 5 companies that we rely on to cross the entire US. So you immediately see trucking is an option, but you have very limited supply available. We will not compromise, and the customers that we deal with, like Energy Fuels, they will not compromise on safety, security, and compliance. But that immediately pushes you into a limited amount of trucking companies that are qualified and that are able to do this. Why is this? Why is it so hard to have more trucking companies get involved in radioactive transport? There's so much buzz in the nuclear industry. There is a renaissance that's happening. Why not more? Well, first, there is perception. Perception undeniably still plays a role. Whenever people see the radioactive placard, it reminds them of, or it makes an association with Chernobyl, Fukushima. Radioactivity is not fully understood, which makes it hard to convince suppliers to get involved in it. There's a lot of training needed. The hurdle to step into that world is quite a significant one for suppliers. A lot of training is needed. Insurance requirements are pretty high premiums. And also the volume is not massive. That is an important element to consider, and I'll come back to that a little bit later. So then on the trucking side, once we ship internationally, we ship ore from Australia to North America, or we ship uranium from here overseas. You use ocean lines. This is a list of the 10 largest ocean shipping companies in the world, the top 10 in terms of volume that they ship. Looking at the ones that actually accept radioactive materials on their ships, you see that 6 are already crossed out. 6 of the biggest 10 shipping lines in the world will deny taking any radioactive materials. It's a non-starter. And of the 4 that are left, 2, Maersk and OCL, will only take it on certain lanes, certain commodities, so not everything, and at certain, sometimes minimum volume requirements. So you see immediately that, yes, ocean is possible, but very limited supply. This is natural material. Once you go to enriched fissile material, the list is 0. There is no liner company that will take fissile material. So you're forced to use a charter company. You actually have to charter a ship to ship enriched UF6 from point A to B. Now, as significant as that is, and as big of an issue and a limitation it is, to select a vessel and select an ocean carrier, it becomes even harder when you look at the ports. There is a certain amount of ports, this is just a random sample of them, that will accept radioactive material to be loaded, stored, or unloaded in their terminals, but many of them come with limitations. So to give you an example here, the port of Shanghai will accept radioactive materials, but only at a certain terminal with a maximum of X amount of containers per shipment. The port of Rotterdam will allow, in certain terminals, not all terminals, certain terminals will allow loading and unloading of radioactive materials. You can keep it on the terminal for maximum 48 hours. So you got to move all your material out within 48 hours. So it's yes, but. Yes, we will accept it, but. And then there's a whole series of ports that will just deny it. Vancouver, where I'm from, they will not allow loading and unloading. There's one terminal outside of the city that will allow it, but they will shut down the entire port. So it makes it really cost prohibitive to use those ports. So we have limited trucking companies. Rail is not always an option. You can use a limited amount of ports, a limited amount of ocean carriers. So you got to make sure that you find in that puzzle, you got to find a solution to identify what are the right ways to actually do this. So as I mentioned, one of the reasons of this is scale. When we talk to shipping lines, when we talk to trucking companies, this is one of our biggest issues. What makes the nuclear industry great is also one of its weaknesses in terms of transportation. And as Matt mentioned, you need very little material to create a whole lot of energy. So this is an overview, it's an estimate of what is the total amount of material that is being shipped in the front end of the nuclear fuel cycle globally by all producers in the world. So this is natural uranium, this is natural UF6, and it's enriched UF6. If you add that up all together on an annual basis, you get to about 15,000 TEU. TEU stands for 20-foot equivalent unit, so it's a 20-foot container. So about 15,000 containers per year are moved globally. This is a picture of the OOCL Hong Kong, one of the largest container carrying vessels in the world. Its total capacity is 21,400 TEU. So the entire world production of front-end material is less than what one ocean vessel can carry on one voyage. And there's a total of about 5,400 of these container ships in the world. So we are a little drop in the ocean in terms of volume. So when you don't have volume and you go to the shipping lines and you go to trucking companies, it's hard to negotiate. Unlike the oil and gas industry, the coal industry, you have much larger volumes to play with. That is the challenge we face. One of the challenges we face. I mentioned the limited amount of truck companies that are handling Class 7 material. One of the things that we're looking at and keeping a close eye on is the future. According to the American Trucking Association, we are looking at a significant shortage of truck drivers. Estimates they make is by 2028, we will have a shortage of 160,000 drivers in the US. That is very, very significant. If you then combine that with the increased requirements, certain commodities that we truck, we need to have 2 drivers in the truck. So you need more drivers, there's less of supply. So I don't need to make a drawing here of what the issue can be. So the availability of truck drivers is a real concern. Another thing that we're looking at is obviously geopolitics. The geopolitical situation has impact not just on radioactive transport, but it definitely has significant impact in shipping in general. I just used one example here, the Houthi rebels who started shooting vessels in the Suez Canal, basically shutting down the Suez Canal for transport in general. What that has done is almost all vessels have chosen to avoid the Suez and make their way all the way around the Cape of South Africa and go all the way around, adding around 8 to 10 transit days on ocean, adding costs. More fuel is being burned, so more costs. What it does as well is, what it costs is a limited of container supply, but because suddenly all these containers were longer on the ocean, so there was a lack of containers available at other ports. So you see that one geopolitical aspect has a really impact and a ripple effect that works throughout the supply chain. So these are, and there's many geopolitical issues. Obviously, the war in Ukraine has caused issues with ships coming from Russia and so on. Insurance is another one. We see from the insurance brokers an increased risk aversity towards Class 7. It's a discussion we have at our company every year when we talk to our broker. Premiums are not coming down, they are going up. In North America, almost all policies will exclude radioactive materials. So separate endorsements are needed, separate approvals are needed. And this is one of the big struggles we deal with suppliers, is explaining to them, you need to have these insurances in place, but at high premium. And a lot of them don't have it. And so there's quite a big hurdle to get involved in that. So insurance is definitely something to keep an eye on. Compliance. Radioactive transport is almost always the first victim, even if it's not the culprit. What we see is shipping lines are really clamping down on misdeclaring cargo. We see that a lot in the rare earth space, where materials that are radioactive are not declared as radioactive. So that's definitely something we're working against through organizations like WNA and WINTI. So this is something where hazardous materials that are misdeclared or are not declared properly, if something happens as a consequence, and there's a few pictures here of fires breaking out on vessels in mid-ocean, very often the response of the companies involved is, we won't take any Class 7 anymore. And Class 7 wasn't the culprit, but does pay the price of misdeclared cargo. So it's certainly something, together with Energy Fuels, we are working on. We're making sure that this is made known and doing it the right way, doing it compliantly. My last point here on future issues is new markets. As we go into new builds, as we go into new types of fuel, which will require different types of packages, which will involve transport going through communities that have never seen radioactive material. When you look at SMRs, there is transport related issues and awareness creation that is needed. So that's something to definitely, where we work together with Energy Fuels on things like that, on engaging communities and making sure they know how this is transported, that it is done safely, that it is done compliantly, and following all the regulations. So in summary, the nuclear and radioactive transport sets itself apart by its very strict regulations, its very strict packaging requirements, and there is a lot of limitations around it. It's not just picking up some uranium at point A, bringing it at point B. Limitations are everywhere around the globe and are constantly changing as well. We're keeping an eye on closely on all of those issues that I mentioned. And I think as we expand as an industry and as there is a nuclear renaissance happening, we definitely need to make sure that we stay on top of transportation, that we need to keep transportation in mind. It is not just something that happens, it's something that really requires thoughtful consideration on how to do it right, how to do it correctly. Yeah, thanks everybody. I'm happy to answer any questions. If any questions, Steve and Jamie are here. Oh, there you go.
So at the end, you just mentioned small modular reactors. So some of the concepts for small modular reactors include things like loaded reactors at the end of 5 or 10 years. Are the SMR companies talking to you about transporting things like this? Are they finding that for that?
Yeah, it's a good question. I would say some are more proactive in that, as it often is in new industries. Some are more proactive than others. But we at TAM, for instance, we've done several studies on behalf of SMR technology companies. And I think especially the aspect of new type of packaging, going into communities and jurisdictions. Canada, for instance, we're looking at SMRs up north. These are communities that are not used to see Class 7 trucks pass by. And so there's definitely an awareness in the nuclear industry of the need to look into transportation and consider that as part of the whole package, the overall package. We see that in other industries, less so, like rare earths, there is a lot more awareness creation needed and where there's definitely more education. So what we do there is we would go with them on site, tell them how to package, how to secure. But yes, there's a lot of SMR companies that we are talking to that are talking to us and are taking transport in as part of the consideration of the overall project. Absolutely.
I appreciate the long-term relationship we have with fans. Everything by the book. Always have, always will.
Amen.
What? Speculate. How many other companies do you run into that do things by the book? I mean, just speculating. I mean, you see a lot of people getting into the rare business, the drinks business, and a lot of them just don't really appreciate that you have to be just any comments we could have in terms of like during the course of a year or something, what you kind of witness, and I know you have to be careful here.
Yeah.
You can't mention companies because you know someone. They make shortcuts. Okay. And I just want people here to know we don't take shortcuts.
Thanks, Mark. That's a tough question here, but yes. No, you're absolutely right. I think the way that we set us apart, and that's why this is such a good partnership, is indeed compliance. We do not cut corners. We do it by the book. One of the decisions we've made very early on as a company is we have our own compliance regulatory team in-house. We don't rely on external consultants, and no, we have it in-house. We built up that expertise, and we're engaged with the industry as part of WNA, WINTI, and so on. Yes, it is often, as I mentioned, we find in nuclear, and whoever wants stories can talk to Steve because he sees it all crosses his desk. We see in the nuclear space, there's definitely a stronger awareness of the need to be compliant, follow the rules. even there's sometimes discussions on like, well, should we lash it this way or that way? But there's no debate about the type of package that is needed, an IP1 drum, or there's no debate really there. Everybody does that and does a really good job of sharing that knowledge. On the rare earth side, it is a bit more challenging, especially because you have companies that have historically, unlike energy fuels, not dealt with radiation. They've done zircon or ilmenite, and they don't really meet the threshold of radiation for transport. So they assume somehow, like, oh, I can do monazite at an 80% concentration the same way, and I can use the same bag, and you cannot. It is not according to the regulations. So that is where there's a lot more education needed, and some will follow the rules, and some will say no, we're going to do it the cheaper way, and we're going to do it the way we do it with other non-radioactive materials. But we know as a fact that, especially in the world of monazite, there is monazite being shipped. I don't have to make a picture here, but to certain countries that are not declared as radioactive materials. So they just ship it as a non-hazardous material on an ocean, and it yeah, and that is the reality. That is the reality we have to, and that Energy Fuels has to face and has to compete with, and that's tough. So that is where we meet each other very well, and that's where no, we're not going to cut in corners. We're doing this right. We make sure that every container is checked. At every port, we have a surveyor that checks whether the container is done right. We make sure there's a lashing plan, there's the right packaging I use. So yeah, that's why this works so well.
That's why I wanted to, it's, just, yeah, that's a good explanation. In the nuclear fuel cycle, there's a longer history.
Yes.
Legacy and all that with doing everything by the book and more checks and balances. But in the rare earth business, with monazite,
yeah.
Less so.
Yes.
A lot of these companies that are operating out of Africa,
yeah.
and the countries didn't mention, but everybody knows who they are.
Yeah.
It's an issue.
Absolutely.
Absolutely.
Yeah.
We pay the extra price. We do the extra checks. We make sure the big works are properly built out, right trucks, the right chips, the right everything.
Absolutely. Yeah, it's night and day sometimes, and yeah, it's a big part for our company too, is to create that awareness. But some don't want to be trained, and okay, then good luck to you.